it's always great to introduce somebody who needs no introduction. And Jim Woodmencey is that person. I think probably by a show of hands, everybody has been on his website to see what's going to happen tomorrow and the next day and the next day. Jim got his Bachelor of Science degree at the University of Montana in meteorology. Montana State.
Yeah, that's bad.
He then took a ranger job saving people's lives for 14 years all over the Tetons. He worked up in Anchorage as an avalanche forecaster. He was a heli guide here for 20 years, and he's been a resident of Jackson for over 40 years. And so every day, including this morning, I look at his website and see what's going to happen. And it's a real honor and pleasure to have Jim here speaking for us today. So please join me in welcoming Jim Woodmencey.
That's like this. Is everything running properly? And do I need to stand in front of this?
I'm working on it.
Okay. So I like to move around. I can.
No, wait a minute, don't say that.
Why don't you walk around once we can hear you?
All right, that's a good idea. That way I can get in front of the people on the other side of the room. How come all of you people aren't at the movie Buried? We scheduled this first, but you can get the movie on Netflix. So, and the only thing you're really missing is Lanny Johnson, who was there, and I've already seen a private showing from Lanny. But anyway, because I used to work with him in parts.
But they can't see you unless you're in front of the screen.
Okay.
Your screen.
Well, once I get going here, they won't need to see me. So you can see me now, briefly. Anyway, like Mike said, I've lived in Jackson for over 40 years now, and not all of that time was I forecasting weather here, although I did have a degree in meteorology. I was out playing in the mountains a lot of the time, but I started forecasting here in 1991. And since then, 30 some years of that, I also have been writing a newspaper column for the News and Guide. Actually, I wrote for every single newspaper in Jackson over that 30-year time period, from the Guide to the Weekly to the Planet to you name it. I wrote a little weather thing for all of them. And sometimes at the same time, I was doing a couple of different ones, which is very rare. Just ask Kevin Olson. And through that, writing that column, it kind of kept me on top of what the weather was doing here. And so from a historical perspective, over the last 30 years, compiling the data, mostly locally here in Jackson, but looking at different weather stations throughout the valley and seeing how those patterns have changed over the years, or how taking the data has changed over the years, has been fairly interesting. It's an interesting study when you can kind of recreate a whole history of Jackson Hole's weather, even going back to before the time I was here, before the time I was born. And I'm gonna say pretty confidently before any of you were born, unless you were born in 1899. I don't think there's anybody in here that's 123 years old. So what I'm going to do is I'm going to try. First, I'm going to take you through where the weather stations are in the valley. And then we're going to look at the type of instruments that they use at those stations. And we'll also look at our averages that we accumulate over time and what some of the extreme conditions were here in Jackson, and sort of define what we consider to be normal. I'll give you a little hint ahead of time. There is no normal. There's no such thing as normal. And then, look at what has changed in recent years, like in the latest 30 years, or even just in the last 10 years. So I'll show you where we have what are known as climate stations. In other words, weather stations that for the most part have been manually read by an observer every day, daily. Not, well, they're supposed to be read every day. They're not, but in a lot of cases. And they're different than other weather stations you might look at. And these are actually harder to find online, local weather stations I'm talking about. So going from south to north, there's a station here in Jackson on the north end of town. There's a climate station in Moose, there's one in Moran, and there's one at the south gate of Yellowstone. I'm going to briefly look at Moran, Moose, and Jackson and talk about those sites. I'm going to leave the south gate of Yellowstone out of it just to save some time. But there's some interesting data that dates back to the early 1900s that comes out of there from the ranger station. Part of the older record up there was only in the summer. The other weather stations that you can access on the internet pretty readily through mountainweather.com or other places, those are not climate stations. They're different instrumentation, and every one of those has a different type of instrument that is associated with it. They're not uniform or they'll differ. Some have just temperature, some have temperature and precip, some have wind. The airport is an automated observing system for pilots to get weather observations right from the end of the runway. And then there's a cluster of instruments at the Jackson Hole Ski Resort, Jackson Hole Mountain Resort, that utilize that data for their avalanche forecasting and operations out there. And then there's other stations. Some of them are seasonal in the mountains in the winter only. The ones up at where it says 19 up there, 19 degrees. Those two stations are up by Surprise Lake, and they're just there for the avalanche season in the wintertime. All of those stations I just showed you, you can access on the internet. And it's on the current conditions page of mountainweather.com if you haven't been there. And you can get a 24-hour summary. You can get 7-day observations, 2 different formats for that. But it's all the same data, just in a different way of looking at it. And then you can also get a forecast for that spot by clicking on the orange button. If you click on more plus on any of these, it'll drop down the menu and there's more stations you can look at. So there's tons of them around to look at around the valley. Again, these are not our climate stations. These are not stations that we're really gathering or have been gathering data for or from for many, many years. This is just more recently that these have been up and running. So the 3 stations I'm going to concentrate on, again, I'll start the north this time, and we'll look at Moran, where it's situated and what kind of data it has and its record, how far back it goes. We'll look at Moose, and then I'll concentrate on Jackson because it's right here. And it also, in my opinion, has the best long-term record of any of the 3 stations. Anyway, on the local climate page, you can also access climate data for Jackson that's coming from the Jackson Climate Station. I've compiled all of that. And then if you want the actual readings from those stations, you can access that as well. There's a little button down here, the Wyoming Now Data button. I don't expect you to remember all this, but you can always email me and I can send you a little walkthrough video on how to access that. That'll take you to a page like this. You can scroll down to Jackson, Wyoming, not Jackson Airport, and then daily data for a month. Pick your month and year and then hit go. And you can also get a whole bunch of other ways of looking at it. It's not the most complete or the most quality controlled, but it is a source for those climate stations that I'm gonna show you. Okay. So let's look at Moran first. The earliest date for Moran was dates back to about 1911. And where I have that little yellow circle up there, that I think that's about where the old Moran town site might have been before the dam, and that's where they were taking weather observations. And then in 1954, it moved to the Bureau of Reclamation office on the other side of the river, and it's been there basically in that same spot. They've moved it around a little bit, but you know, not more than 20 yards over those years since 1954. So it's been in the same spot. So it has a pretty good record. Again, it doesn't have the most continuous record. There are missing days. It depends on who's been working there and how dedicated they were to taking those observations. And that's one thing I would like to point out is it's the people who are manning these stations, and it's usually government workers, Park Service, in this case, Bureau of Rec, or Forest Service here in Jackson, that have taken those daily observations day after day, year after year, to compile that record that we have. Moose, originally the station was at park headquarters when it was located up at Beaver Creek, just south of Taggart Lake Trailhead. And it was continuous there pretty much from 1935 to 1958. And then it moved down to Moose when they had the new park headquarters, was moved down there or built down there. And recently it moved from the north side of the road, where the old kind of park headquarters scene was, to an area that's now on the south side of the road by the new visitor center. And over time, you know, there's been more development on that north side of the road, of the Teton Park Road, a lot more asphalt since the 50s. And so now it's in a better location, I think, where it is now. There's a lot of criteria that I'm not going to go through about siting these climate stations. And there's all kinds of problems with other stations throughout the world, but especially throughout the United States, where you've had cities basically grow up around an established climate station. So you either keep moving the climate station further and further out of town to get more of a rural feel to it, or you just leave it where it is and you end up paving the parking lot and putting up buildings, and that changes the weather that you are recording. We're lucky here at all three of these sites that the surroundings have remained almost unchanged. Moose changed a little bit. Jackson's changed a little bit. Moran's changed very little over time. So the Jackson climate station, this is really interesting because it has some of the oldest records, and I'll show them to you, that date back to 1899. And as near as I can tell from the metadata or the site map that's available as to where they think these stations were back then, it looks like back in 1899, it was taken on an area out closer to Wilson, actually, by the Snake River, somewhere in that little box that you're looking at up here. Not sure which side of the road. Could have been the Walton Ranch, or could have been whatever that ranch now is to the south, right before you cross the river. And that's the best I can tell you. But there's only 3 months worth of data. This is the oldest record that we have. And you'll notice it says September 1899. And then they broke the thermometers on the 10th of September. So there was no more readings after that. And the other thing that I thought was worth noting, again, 9 of 1899, just looks so weird to see that. And then these are the temperatures in early September, so it looked like a pretty nice Labor Day weekend in upper 70s to near 80. And then this was October, so it looks like on the 10th of October they got new thermometers. Took a month, you know, by horseback from somewhere, and started taking continuous readings for the rest of October. They must have taken Halloween off. It was clear, so they're probably out hunting or doing something like that. So the other thing you might note at the top of these is that Jackson and Wilson both were part of Uinta County at that time. It wasn't Teton County. Just, you know, a little bit of history there. And then the name that's been signing these in 1899, the last name is Simpson. I don't know who W.L. Simpson is. That'd be for somebody else to do the going back in the genealogy and looking at that. Okay. But, you know, nice in the 60s, in the end of October. And then we get into November. This is the last month we have from 1899. And I don't know why that was. Maybe they broke more thermometers and just said, the hell with it. I'm not doing this anymore. Same guy though. But this is even more interesting, is that there was no snow through the 30th of November in 1899. And the temperatures, the average high temperature was 37.3 and the average low temperature was 19.9. This November, just as a comparison, our average high temperature for the month was 27.7 and our average low was 15.8 degrees. Quite a bit colder. As a matter of fact, this November, 2022, is the coldest November ever recorded throughout our entire history that we have records for in the town of Jackson. And I think most people would agree it was pretty darn cold through most of November. They didn't have any snow in November 1899. We had about 21, almost 22 inches of snow in town recorded in Jackson, which is big for November. The average is more like 9 or 10, something like that. I don't remember every number, but some of them I do. Okay. So for a short period between 1904 and 1907, there was observations also taken from that same general area and kind of on the west side, you know, kind of about 5 miles west northwest of town. And it wasn't until about 1916 that the instruments, whatever they were at the time, and I have no idea what they were using, moved into town. And what the metadata tells you is it was located about 2,000 feet north of the post office. So if anybody knows where the post office was up till 1948, let me know. But 2,000 feet would, you know, what, almost a half a mile would put you close to where the existing Forest Service office is. And that's where it moved to in 1948. It may have moved there prior to that, but at least the data, the historical data is telling me that it was maybe not where the building was. The building on the north end of town, the Forest Service building, was built in 1937, I think it was. So it may have been in the same place since roughly 1916 or at least 1936 or 7. So these observations kind of prior to 1930 were really sporadic. You know, some would just be in the summer, maybe the few months in the winter you would get some data. And so you can't really, and then some months were really complete, like this one, where they, for the month of January, and they crossed out Wilson up there, but we're still in Uinta County at this point. And this is in 1905, January of 1905 is what we're looking at here. And it looks like somebody, the last name of Palmer, was taking the observations then. And the a little bit of chicken scratch on there that I can't decipher, kind of right in the middle here. I'm not sure if those are supposed to be zeros or trace or what, but there's a 2 and then there's, you know, one of the cryptic T's or whatever is crossed out. It doesn't, you know, I need somebody that can decipher handwriting, but I don't know what that little squiggly denotes. But at the end of January, they had a whole bunch of snow. Looks like about 18 inches in the last 2 days of the month, where at the beginning of the month they only had that's depth of snow on the ground, what I circled in blue there, and that's only 2 inches of snow on the ground first week of January. looks like they did take New Year's Day and the day after off because there's no observations up here in the first 2 days of January. But then it really dumped at the end of the month and they were up to about 27 inches of snow. Compare that to this January. This would be January 2023. Tried to line that up as best I could. We actually had a snow depth in the first part of the week of 14 to 15 inches of snow on the ground already. A lot of that came in November, and then it kept coming in December. And then by the end of the month, we had 20 inches of settled snow on the ground. So they actually ended up with more snow at the end of the month and had more snow on the ground in 1905 January than we did in January 2023. This is March, and that's a complete record. Every day of the month had a observation in it. And this is sort of, again, they're crossing out Wilson and putting in Jackson. And the name at the bottom on this one is Mrs. looks like N.M. Ely. I'm assuming that's whoever had the ranch at where Ely Springs is, kind of west of the high school, was taking the observations. And back then, in those early years when it was still sort of on the west side, it was ranchers who were taking these observations. It wasn't government workers. It was just ranchers that had an interest in keeping track of the weather, as they still do today. So again, here's the old Forest Service office, older Forest Service office, and the old Forest Service office on the right. And it was behind these buildings that they had established kind of the first real weather station. And this is a recent satellite image photo of looking down at that area behind the Forest Service office. And it moved around a little bit, but not very far, as they kept building new buildings and they kept shuffling the weather station around to different spots behind the Forest Service office. And then in 2012, when they were developing, they built the new, they had the newest version of the Forest Service headquarters was built. And then they also started developing all this other stuff, like the Hidden Hollow apartments, which has always been baffling to me because one, they're not hidden and they're not in a hollow. I don't know where they came up with that, but it wouldn't have been what I would have chose. I wouldn't tell you what I would have chose. Anyway, so now it's up by the visitor center, the National Elk Refuge Visitor Center. These were the locations behind the Forest Service before they moved it. So the number 3 is where it was at the last go around before they ended up moving it up north. And this is a picture I got from the Montaigne family from the top of Snow King, looking north, and then one I took in January of 2017. The town hasn't changed a whole lot. I mean, there's a lot more buildings and everything and a lot more pavement in the summer that, but the streets are all snow covered in the winter. And where that weather station has lived, at least since, let's say, the 1940s, is right on the edge of the elk refuge. And that land hasn't changed. Its character hasn't really changed in all those years. And so that's a huge advantage to getting a good, solid climate record for any location, is that you don't change the characteristics of the ground near your weather station. And this one's going back, this is 1950 from the Historical Society. And it really, where the station is, that general location near Flat Creek, is not that much different. The only thing that's really changed is population of the place. And I think that's the 2010 population that I think is on the signs as you enter town. But the 2020 census has us over 10,000 people now living in the town limits. So, we've increased our population almost tenfold in that amount of time, and paved a lot more streets, that's for sure. This is where it was located at the Forest Service building, before they moved it to the Elk Refuge headquarters. And these are the instruments that are involved with the climate station. That big box in the front is called a Cotton Region Shelter, or CRS. It's also known as a Stevenson screen, and the thermometers sit inside of that. Okay. Over here you have a precip can and a snow stake, and then this thing in the back is actually an automated precipitation reading device called a Fisher-Porter rain gauge. And that's not associated with the climate station, but it does record precip. It's not as accurate as the red circled can there, because that's manually read every day. Same with the snow stake circled in green down there. That's read every day by an observer. The other one's just recording stuff, and whatever falls in there, it gives you erroneous readings. Sometimes it'll show it rained or you got precip when you didn't. And so they're a little finicky that way. The interesting thing about this Stevenson screen, which I'm going to talk about here in a minute, is the guy who invented it in 1864. And he was the father of Robert Louis Stevenson, who wrote a couple books. So did I, but yeah, his books were more widely read. Anyway, inside the Stevenson screen, and again, here's the close-up of that precip can. This is the way it's configured in the wintertime, to just let snow accumulate in it. Then you have to go melt it down and measure the water content of it. You have a total snow stake and a storm board, which is in this case is kind of partially buried right now in snow. So those are the observations. You're going to get water, snow, new snow amount, and also current snow depth. Inside the Stevenson shelter, there's two thermometers at the top. I'll show you a close-up of those in a second. The looks like a yardstick across the top is what you measure the water amount with. And then this tall tube that's sitting right here is what you pour the melted water into, and then put that dipstick in and measure in hundredths of an inch of water is what that stick will measure. And then the box sitting down at the bottom of the shelter is what's called a thermograph. And it's kind of a backup to the thermometers, more modern day. Well, not modern day, but post old guy day, when they were breaking thermometers right and left, they didn't have any backup. This was their backup, up until 2012. You've got a minimum and a maximum thermometer, and they're supposed to be alcohol thermometers. There were years, I am told, that they were still using mercury thermometers for some of those, which they would get away with in the summer. But the problem is mercury freezes at -40. So if you want to get a temperature colder than that, you need a different thermometer. Otherwise, -40 is as low as she'll go. And we've gone lower than that. But anyway, these were manually read and manually reset every single day, or were supposed to be. This is the new instrument station. It's just outside of the back of the visitor center. So you still have the precipitation can, you still have the snow stake for the storm snow, and then they just use this area here to, pretty simple, just put a ruler, like a yardstick, into the snow and in a few different places, and you get an average snow depth from that, and that's what goes on the sheet every day. And then in the back of the building here is the new thermometer. I just threw this in. This is where they moved that Fisher-Porter rain gauge that automated rain gauge to, if you're at the visitor center, you turn into the parking lot, in the first possible place you can at the visitor center as you're going north. It's straight across from you. It's on elk refuge property. You can see the buck rail fence there. They're building another giant building right behind this fence, for something, I don't know. The red, what I circled in red up there, that's the thermometer that's on this station. And this is the station that you can access 24/7 on the internet. It's the Jackson weather station, not the climate station. Okay, but make a note of that, that little housing, that thing that looks like a little accordion. There's a electronic thermometer inside of that, the thermistor. Anybody have a home weather station? Is it glass or thermometers, or is it electronic? Yeah, does anybody have a glass thermometer nailed to the back of their house somewhere? Great. Yeah, you can tell on the bottom of a mercury thermometer, it's pinched before you go to the bulb. And alcohol one won't have that pinch on it. Anyway, so that's a thermistor that measures temperature. This is the temperature sensor for the climate station now. And almost everywhere across the United States, they started doing this in the 90s, switching over from taking manual readings with liquid and glass thermometers. There's advantages and disadvantages. To me, the liquid and glass thermometers are more accurate, especially the type that they were using, but it has to be read every day and reset every day. And they're prone to breakage, as the cowboy showed you in 1899. The advantage to these is that it gives you continuous readings 24/7 and nobody has to touch it. Long as, well, even when the power goes out, it'll still somehow record the temperatures, as far as I know. But it does require some kind of power, whether it's solar or electric. These are hardwired. So MMTS is a max min thermometer system. This one is made by a company called Airflow, and it's been in place there now since 2012. When I was kind of researching, some of the ups and downs of changing over and how that might affect your climate record, in Australia, they've been studying this. Maybe, well, there's some people in the United States that have been looking at comparisons too. But the one thing that struck me was that the thermistor probe, the new type thermometers, the electronic ones that we're using, will tend to give you a little higher temperature or lower temperature because they're measuring instantaneous temperatures. And the liquid and glass thermometers took a slower amount of time to reach the maximum or the minimum each day, where these will spike. It's sort of like an instrument that's measuring wind. You average the wind speed over like a 15-minute period or half an hour or an hour, and then that's your average. And then whatever the spike is, that's your gust. So an average wind speed isn't an instantaneous wind speed, and an average temperature for the day, or I should say a maximum or minimum temperature for the day, is not a spike. It's something that should be, because that's the way it had been done, for, well, in other places over 100 years. And so I have a little bit of a problem with that, but not that much, because the ones they're making now have a pretty big range on them. And so they can measure a wide range of temperatures if it gets really, really hot, or in places like the desert. And it can also measure really low temperatures. And yeah, they break, but they probably don't have the same incidence yet of breakage that the glass thermometers did. Okay. So what affects the temperature? What makes the temperature? First thing is that the sun is heating the ground, and then that heats the atmosphere from below. The upper atmosphere doesn't really heat that much as sunlight translates through. So it's basically heating the ground surface. That's the first thing that it's doing. So the things that are important to sighting your instrument are what's the ground cover and what's the albedo of that ground cover most of the time. And I don't expect you to be able to read that little graphic up there. I'll show you another one that describes it. But snow reflects most of the incoming sunlight, so it doesn't absorb much. But concrete or pavement absorbs a high percentage. So albedo is the amount of reflectivity of the incoming solar rays. Okay, so you don't want to have it on a concrete slab. You don't want to have your thermometer sitting on, well, in the winter it sits on snow, but that's normal. And then you don't want it buried in the woods either. The other thing that will affect the temperatures on any given day is how much cloud cover we have. And we all know that intuitively. If it's a cloudy day, the ground doesn't heat as much and doesn't get as hot during the day. And at night, if it's cloudy, it doesn't get as cold because long wave radiation, outgoing long wave radiation isn't free to move out into space. So the temperatures don't cool down as much. But when it's clear during the day, you can heat the ground better. And when it's clear at night, you can cool the ground better. Okay. And then the other thing that will affect temperatures is the weather pattern that you're in. If you're under high pressure for many, many days, you can build up, like in the winter, we might build up temperature inversions, and that'll make it really cold in the valley for many days in a row. But if the weather's changing, then we'll be cold for a few days, and then we'll warm back up, and then we'll get cold again when the high pressure builds back over us, and then we'll get warm again, kind of like we did in December. I didn't put a graph on here, but does anybody remember what it did in December? What's that, Bob? It went back and forth like crazy, like 50, 60 degree temperature swings in a day between what the day before's high temperature was and the next morning's low temperature, and then vice versa. There was days that and December is kind of notorious for that. It did the same thing in 2016. There was 50 to 60 degree temperature swings within a day or two in Jackson. Anyway, so these things are all going to affect the temperature reading on any given day. This I just pulled off the internet to give you an idea of how much of incoming solar is reflected off of different surfaces. So snow, fresh snow especially, isn't absorbing much of the sun's heat. So you can look at this in the opposite way as well. The lower the number on here in red, the more solar is absorbed. So the more readily the ground can heat up. Okay, so in the winter, we don't really have to worry so much about that because it's snow covered. This is where the new Moose station is. That's what it looks like in the winter. This is what it looks like in the summer, just kind of in the sagebrush, bunch of dirt, kind of away from the thick forest or the trees there. This is the 24-hour board and the total snow stick on the left side. And you can see the same instruments in the summer. You can see the rain gauge over here on the right-hand side. Right here's the rain bucket. You might have noticed in this photo, the rain bucket is kind of buried almost, which they should attend to that. But I was up there the other day to look at it, and it didn't seem like they were paying much attention to it. Anyway, you can see what the ground looks like in the summer in that photo, and here. That's the thermometer housing for their electronic thermistor. And then it's run, it's got a solar panel there, kind of right next to it. Sure, I would have done that. It's actually the thermometer is right behind the solar panel. I don't know if that affects it that much. But the ground cover here is completely different than what is at the Jackson station. Jackson is green grass. It's, you know, closer to the creek. This is, you know, not far from the river, but it's very, very dry in the summer at that site. There's not a lot that's getting reflected off of that dirt. It's mainly getting absorbed, where in Jackson, it's getting, you know, the grass doesn't absorb as much as the bare dirt. Okay. So just from, let me just kind of walk away from this for a minute. Just because I'm getting stiff standing in the same spot. Just as a show of hands, from your experience living here, which is the warmer location, town or Moose, Wyoming? How many say town? How many say Moose? Because you know it's a trick question. Well, it's not just because the weather station is on dirt. That has maybe something to do with it. But throughout history here, Moose has always been colder than Jackson until 2018, when they put this weather station. And it bugged me because I look at the weather. Mainly I look at, you know, the monthly data for Jackson, but periodically I'm looking at Moose and Moran and Southgate, Yellowstone. And what I noticed after about mid-July or August of 2018 was that Moose was experiencing a lot of 90-degree plus days when Jackson wasn't, at least according to these thermometers. And so I investigated it a little bit closer. So here's what I found. Here's data from, this is right off the internet. You can look this up yourself if you want to. On the left is Moose, August of 2018. So the month after they installed the new instrument there. This one had been in since 2012 in Jackson. So I got Moose left, Jackson on the right. I've got the maximum temperatures over here on the left in the red column, and maximum temperatures for Jackson in the red column. And I started looking across at various temperatures, seeing, well, it was a high of 87 on the same day. It was 78 in Jackson. A 9-degree difference. 95 versus 84, that's an 11-degree difference. Another 95 and 90, only a 5-degree difference. But you can kind of see the pattern here almost every single day, except days it was precipitating, days it was cloudy and raining. Then the temperatures lined up much more closely. So on this day, the high was 71, it was 69 in Jackson. Not too big of a difference, not something to get too excited about. But there was precipitation that occurred that day and the next day. And you can see it was 51 and 54 the following day when they were getting more precipitation. So, you know, if it's cloudy and wet and raining, it's not getting a lot of solar, it's not overheating that thermometer or the ground, I should say, more likely, right? So the average temperature in August of 2018 at Moose was 81 degrees, and the average temperature in Jackson was 76 degrees. And unfortunately, Zoom is not allowing me, so I have to do math in my head. That's over 6 degrees of temperature difference, which is almost unheard of. Did I do my math right? 5, something like that. So then I looked at low temperatures, which again, these are being, you know, what you're getting is an overnight low overnight, right? When there's no sun. They match up a lot closer, but Moose still came out just a little bit warmer, you know, by a little over a degree. like 1.9 degrees warmer with the thermometer they're using at Moose versus the thermometer they're using at Jackson. So that sort of reaffirmed to me that during the day, especially when it's sunny, that thermometer is in Moose is probably reading an exaggerated temperature. Okay? And I don't know, well, I know now, but I didn't know then why. And I assumed it was because of where it was put on dirt versus grass. That's part of the story, but not a whole story. So I thought, well, let's look at Moose versus Jackson in a year before these fancy electronic thermometers, when they're still using the liquid and glass thermometers. And here I've got Moose on the left again, Jackson on the right. And sure enough, in 1988, which by the way, was the hottest, driest summer ever, combination of hot and dry. Jackson was warmer by 5 degrees. There's another day Jackson was warmer by 8 degrees. There's another day where Jackson was warmer by 4 degrees. That seemed normal to me. That's what I was used to up until 2018. That's what I would expect to see if I was comparing climate data from a month, observations from a month at Jackson versus Moose. Average temperature was 83.6, Jackson's was 85.5. So you got a 1.9 degree temperature difference, cooler in Moose than Jackson. That seems perfectly normal. And that's, if you went back, you could almost pick any summer month and but prior to 2018, and that's kind of what you would expect to see. So between 88 and 2018, something changed from Moose being 2 degrees cooler than Jackson in the month of August in those examples to being over 4 degrees warmer than Jackson in the month of August. So that's swinging 6 degrees. That's too much when you're averaging temperatures like that. You don't see that kind of radical difference. And topographically anyway, I mean, you're only talking a couple hundred feet of elevation gain, so that's almost insignificant. But for daytime high temperatures, that just doesn't seem right. So what caused that to happen? Again, I thought about ground cover, the albedo effect there. I thought, well, maybe they get more clouds up there because they're a little closer to the mountains. None of those things seem to fit. So I went up and measured the damn things. And here's what I found. My hand is the same size. But the housing that the thermistor, the thermometer is inside of, is much bigger than in Jackson than it is in Moose, as it should be. Because you want air to flow through there to keep that cooling. In other words, like your car thermometer, you park your car, your thermometer is going to shoot up. Keep it moving and it won't. Same here. This is a stationary thermometer probe inside of these accordion things here, and it needs to have air circulating in it. Okay. If you have a smaller space, airspace that the thermometer probe is in, it's going to heat up and it's not going to circulate the air through it as readily as it would if it had a bigger housing. I mean, look at the size difference here. The height is almost 50% more. The diameter is almost is twice, more than twice the diameter, and the circumference that I measured again is almost twice as big around on that one. When you go back to the Stevenson shelter, you had a lot of space, a lot of airspace. Matter of fact, in really hot locations, they put a real low speed fan inside of those in the summer to keep the air moving. Who knows what the hottest temperature on the face of the earth is or ever was recorded? Close. Can I get a 170? Can I get it? No. 134 degrees in Death Valley, California, back in early 1900s. I can't remember the date now. I don't know why. But they think that that temperature might be bogus because it's supposed to have been in a Stevenson shelter, but they think there was a sandstorm that packed the louvers and didn't allow air to flow through. And I got this information from a guy named Christopher Burt, who's used to be the weather historian for the Weather Channel. Christopher Burt is related to Struthers Burt, who had a ranch up by Moran for years and years. They're a local family. Very interesting story there. Great guy, got great stories about, he wrote a book about, it's called Extreme Weather, and it's about all the weather records kind of around the world and in the United States, but excellent book and a lot of really good information there. But anyway, he tells me these stories about, because he goes around and tries to, gather investigative work, a little bit like what I'm doing here, and debunk these record temperatures or prove them up as valid. So let's look at moose in December. Take a winter example and see if there's big differences. And here's the kind of same day. Jackson was a little warmer, had the same exact low temperatures. Again, we got quite a bit of snow in December. It was cloudy. There was lots of snow on the ground. So those thermometers were actually working in unison pretty well. There wasn't anything to heat up that little tiny can versus the bigger can. It was just cold. So it was doing a good job with cold temperatures. I'll mention this about moose is you see all the M's on there? That's missing data, or it's supposed to be missing data. So there's days that they didn't record precip, that I know there was precip, where Jackson was taking those readings every day. So the more M's you get on a sheet, the more data you have to toss out. Because at the end of the month, when they total all this stuff up, there's more than 5 days of observations missing. The month gets tossed. It's out of the record, and you can't incorporate it into your long-term climate record. It's a 1 month with more than 5 missing days. Toss the whole year out. I can't give you a mean temperature for the year at the end of the year because somebody didn't take an observation. I can't say that December here, somehow they totaled up 26 inches of snow, but there was probably more, and there was probably more water because they missed a bunch of days. So Jackson was wetter and almost a little less snow than Moose. So that's why it's kind of important to take all those observations. And this is one of my favorite quotes, and it came to me as I was sort of researching for this talk and looking at those thermometers. Nature, when rightly questioned, never lies. And so you can look at the data, and if you don't dig in deep enough, you're going to believe it. And you would be basically getting misinformation, or I hate to use that term because it's overused now, but you're not getting correct information because something's changed. So that's why I question these thermometers, just because I didn't think it was natural to see Moose being warmer than Jackson summer after summer for the last, I don't know what it is now, 5 years or so. Okay. So let me switch gears now and talk about, take all that data every month, every year, blah, 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 and you get averages for each month for temperatures and precip and snowfall. But it's really the extremes of temperature and precip and snowfall that make the averages. There is no average. The average is something we gather from all of those observations that we get. When it's, hotter than normal, colder than normal, or like in December, you go from, 40 above to 40 below or 30 below, it averages out. So you can have a month that's got a lot of extremes to it, then it can come out pretty close to normal, pretty close to average. Average doesn't mean like living in the tropics, where it's a high of 80 and a low of 75 every day. It's just not that way in the mid latitudes of the United States. You can get all of that information. I've compiled the monthly averages, long-term record, taking into consideration all the months that we had complete data for. You can get all the averages for each month. And you look at like February, for instance, average high is 32, average low is 7. Is it ever? Hardly. So when people come to visit, they expect the high to be 32 in February and the low to be 7, and they show up and it's, 20 below. Okay, how's that happen? Well, if you click on more plus on these, it'll give you what the record high was and the record low was in each month for the town of Jackson. And also the record amount of precip and the record amount of snow. And you might notice on this one, we broke new records in 2017 and 2019 for both, 2017 for precipitation, water amount, and in 2019, 55 inches of snow fell in Jackson in the month of February. That was actually the second snowiest month on record in February. I think it was December. Don't remember what year. We had 56 inches. So it was within an inch of being the snowiest month ever recorded in the town of Jackson. What was the coldest temperature we've ever had in the town of Jackson? Does anybody remember that? What was the temperature? Minus 63. That's the number everybody always quotes. That's not true. That was not on an official thermometer. This is the official reading on January 1st, 1979. Day before it was minus 49. Minus 50 is the coldest recorded temperature officially in the town of Jackson. The minus 63, I think, came from thermometers up at Craighead's above Moose. And I think somebody else told me that the cable company had a thermometer somewhere on their building that also recorded a minus 63. Those are different thermometers. They're not official. I don't know anything about them. It's like your car thermometer. I don't trust it. Okay, might be close on a lot of occasions, but I don't trust it. Interesting here in January 79, it went from minus 47 to plus 38. Difference of 85 degrees over 4 days. Do you think we adjust to that very well? No, we all get a cold right after that, right? But that's kind of stuff that goes on here all the time. This is a major swing here because we haven't seen minus 47 since then. The reason I can say with confidence that it wasn't minus 63 officially is because in Moose, it only got to minus 46. That's their official thermometer on the same day. And this is the coldest temperature ever recorded in the valley officially, which was minus 63 degrees. And it was, minus 52 degrees in December of 1924. Excuse me, let me back up. That's the coldest it's ever been in Jackson, is minus 52 in 1924. And the note on the bottom here is it's believed that the minus 52 is about the only data that can be reliably used. It looks like they broke their maximum thermometer and then they just had their minimum thermometer. So minus 52, town of Jackson is the coldest. Coldest ever in the valley and in the state of Wyoming was minus 63. That was at Moran, very complete record. And that was back in 1933. And there you can kind of see it. It's real fuzzy, but it's minus 63. And then it's confirmed over here on the other side that the minimum temperature for the month was -63. And so that's the coldest for the whole state. Bob?
They change from mercury to alcohol thermometer.
That's a good question.
Can you repeat the question for the Zoom?
Oh, when did they switch from mercury to alcohol?
Yeah.
About then.
Instrumentation change.
Yeah, they, if you read this, Moran had a temperature of -63 below zero reported on February 9th. Lowest temperature ever recorded in the state of Wyoming. It still is, as far as I know. All thermometers in the park register only as far as 60 below and were apparently designed to record only indoor temperatures for Wyoming. Now, maybe when the power went out the other day, you got, I don't even know if your house would get down to 30. It got to 33 below officially here in Jackson. That's as cold as we've been officially in town for 33 years. And that's when the power went out. And you can't, don't blame my wife. She works for Lower Valley. Anyway, they were replacing them with ones that went down to 75 below. Coldest year on record still blows me away when I think about it. 2019. Taking a whole year record where you had a year that had records all the way out through. For annual high temperature, it was the coldest. Annual low temperature wasn't exactly the coldest, but it was the annual mean temperature of 35.4 degrees, which is, you know, a little more than 3 degrees colder than the long-term average. But, you know, you're talking about, you know, tenths of a degree here, differences in those years. But 2019 was really remarkable because it had the coldest annual high temperature, coldest annual mean temperature, coldest October we ever had on record in 2019, snowiest February ever, which I already talked about. And, you know, compared to our average snowfall in February, 55 inches is like mind blowing. Yeah.
How many good years do you have out of the whole?
How many good years do I have left?
No.
Personally?
What's the records?
2.
You don't have to think about it, you don't have to throw out.
Yeah, I'll show you. I'll show you the ones that you don't have to, or that you don't have to throw out, that you have continuous records all year. Just as a side note here, I'll transition to summer temperatures, but coldest July ever, 52 degrees. Coldest temperature in ever, high temperature in July was in 1993 on the 4th of July. And that was also, that was also the coldest and wettest summer in Jackson. So let's talk about high temperatures. Hottest temperature ever recorded, 101 degrees. Haven't seen that or even come close to it here in Jackson since. That was also in 1934, back in the Dust Bowl years, you might remember. You know, the coldest low temperature we ever had in the month of July was 24 back in 1954. But this, you know, I have the record that I can see with my own eyes. And what really confirms that it wasn't a misread is that a couple of 3 days later, it was also 101 after resetting those thermometers. And so there's 2 dates in that July of 1934. Our average highs in July are 82 and low is 41. There was 15 days of 90 degrees or warmer, but if you count them up, there was about 10 days they didn't record high temperatures. Go ahead, Mike.
1988, the highest temperature, you pull that up,
I think it was 98.
1988.
I might have that in here. Yeah, I might have that in here. I know it's at least made 95, but it's, you know, part of what makes the hottest month is consistency. In other words, a lot of days that are over 90. So in August of 1934, there were 10 days of 90 degrees or warmer with only 5 missing days. July had 10 missing days, so there could have been more days to that total of 25 days in the summer. There weren't any in June. 25 days in that summer that were 90 degrees or hotter. One of the hottest summers that we've had here temperature wise, you know, consistently was 2003, and that had 29 days total of 90 degrees or warmer. I suspect that 1934 had as many or more. It's just there was a lot of missing days in there. So not too much difference there between 1934 and 2003 as far as temperatures go, but 1934 still holds the record for highest temperature. So to wrap this up, I just want to talk about what's changed and compare data more recently in the last 7 years. I'll look at first because it's most forward in our memories. Every year for the last 7 years, the average high temperature in the town of Jackson has been below normal. The average low temperature, annual low temperature for the whole year, there's only 2 years out of those 7 that were below normal. And then as far as mean temperature, 3 years that were below normal temperature wise. 2020 is the only year in the last out of the last 7 that had below normal precipitation. We've had above normal precipitation 6 out of the last 7 years. And snowfall, we've had above normal snowfall, annual snowfall, that's for calendar year, every year except 2021 when it was right at average, 77 inches. And that's the long-term average going from 1905 to 2016. And there's a lot of ways to break down what you're using for your averages or your normal. I like using the long-term record, especially those years, and compare the more recent years to that. But you can accumulate all the years together, and I'll show you how that kind of pans out for some of these. A lot of climate studies will only include or they'll compare to normal. They'll consider what's normal 1981 to 2010. The latest 30-year period is now 1991 to 2020, but some people haven't switched over to that yet. 2019, coldest year ever, coldest October ever. 2022, 4th coldest year on record, and the coldest November ever that we just lived through. And so this is, I think what you were alluding to, is weeding out all the records that don't. I wish I could get rid of this dang thing. Let me see. We'll just move it somewhere up there so you can see the years at the bottom. So this is updated basically almost the last 100 years, and the holes in it are years that didn't have complete enough data to make the cut, because it's calculating, and I'm calculating an annual mean temperature. So I need the whole year, every month, with not more than 5 days of missing data for every month for all 12 months of the year. The trends here, if you can pick them out at all, would be something's whack now. Let's see. All right. So this is going back. This is 1933. I couldn't include 1934 in there. I know that was the hot July and August because it didn't have complete data. So 1933 was actually the warmest year we ever had on record for annual mean temperature. And then this block of time from the mid 40s to the almost mid 70s was actually kind of a cold period. We were mainly riding below the average line, which is the historic average line, which is the green line. And then in the 90s and early 2000s, we popped back up above average. And that, again, 2003 is in there as being one of the hottest summers on record. And then since then, say 2010 or so, again, there's a few missing years in there, we've been riding below average for annual mean temperature. So the blues are representing periods of colder than normal for a whole year, and the orange blocks are warmer than normal for the whole year. Also, the number of days that we've been 90 degrees or hotter, pretty obvious. There's 1934, 25 days with possibly some missing. And then we had 29 days in 2003 for the whole year, for the whole, it's basically just in the summer. But 2018 was the last time we officially hit 90 degrees. Everybody's car hit more than 90 this summer in July, but the official high was 89 in Jackson this last summer. And so we've got a pretty good string there of over 10 years now with just one day over 90. On the flip side, days that were below zero between 1923 and 2000. I include 1923 because it's one of the few years in the 20s that had a complete record. So I thought I'm not going to throw that away. But it was back in 1944 that had the 70 days of the year with 0 degrees Fahrenheit or colder. Second place was last year. 68 days last year in 2022. And then 2019 or 1952 is in third place with 63, and 2019 is in fourth place with 62 days.
The missing bars indicate the data was missing or was not.
No. With this, you can take, as long as you have the winter, there might have been some missing days, but what I tried to do is if there was too many missing days, I just tossed them on. But you know, like with the 25 days in 1934, I just included it because it was a lot of days. But if they're missing 10 days of record, then that month, those months go out. So these are just kind of winter months, say November through February or March. And then the summer ones are the 90 degrees are for just summer months. Go ahead, John.
How come in the 80s there wasn't any
Laziness. Somebody just figured that it wasn't worth doing, or they didn't know who was supposed to do it, or I don't know. Yeah, it's a little disconcerting that way. So let's talk about snowfall here, because this is one of my favorite subjects, but I'll go through this pretty quick. But I came across this quote a few months ago, and it was a prediction by this guy who was on the panel of the IPCC, and he basically made this statement that within a few years, winter snowfall will become a very rare and exciting event. Children just aren't going to know what snow is. Previous picture was me skiing in February of 2020. There wasn't any lack of snow there, but it was an exciting event. And I don't believe that will happen. And the main reason I believe it's not going to happen is because this guy made that prediction 20 years ago in the year 2000. And as soon as he made that prediction, it started snowing like hell here. These are all the winters that we had more than 100 inches of snow in Jackson, and for the winter months. And you might remember 2016, 17. That's when the whatever was there next to Jackson Bowl at the time, the gym center or gymnastics center collapsed. It's also when the power lines went down in February on the Village Road. 2018, 19, that winter, there was avalanches behind the TJ Maxx, and then the skiing was just really good all those years. And here's what it looks like for the years that have complete winter snowfall data for the town of Jackson. And we had some big years. The biggest one is back here in, I want to say 66, 67, 153 inches. We came, the closest we've come to that was in 2008-9. And then again in 18-19, I think it was, we had 119 inches of snow in town. So there's, a fair number of 100-inch winters in there. Same thing at the mountain resort. And you can kind of see this is a 5-year moving average for both of those graphs. And here's the interesting note on the Rendezvous Bowl site, which has over 40 plus years of record now. Is 8 of the top 10 snowiest winters at this site at the Jackson Hole Mountain Resort, the bottom of Rendezvous Bowl, have occurred in the last 15 years. So see, if that guy would have waited on his prediction a little bit, he might not have said that. Because he said that 20 years ago. Okay. And then the final slide here is POR is the period of record. So taking all the available data from 1905 to 2016 and looking at the precip and the snowfall in the red blocks, that's what it was for the period of record. And this is the latest 30-year numbers that we'd be working off of now. Pretty good jump in Moran. I suspect that this number here was maybe underreported or under-recorded. And you know, a lot of missing data where the same would be true here in Moose in the last 30 years with all that moving around that they did. I think they just got tired of taking readings. But you know, this is more like the number you would expect. In Jackson, if you look at just winter and you take into account all the years, we're pretty close to 80 inches of snow on the average now. So that's those numbers have increased. But anyway, I got 5 minutes or so to answer any questions you guys might have, but I think I've given about every piece of data that I can think of. And if you're not a numbers person, you probably should have just walked out of here. Yep. And do I need to be here or can I?
You can walk around.
I'm gonna go. I'm not gonna go. I'm just gonna go. All right. The Moose, yeah, it moved a few times over by the old headquarters building, kind of in that vicinity. And then they moved it to the new visitor center. It was, yeah, not as dry. There was more grass and then there was more trees to the south of it a little bit. So maybe it was a little more shaded that way, not as open to the sun as much. But I that makes some difference, but I'm convinced it's the size of the housing that it sits in. It's just not aspirating enough. It's not ventilating well enough.
That's what I was gonna ask, is vegetation, transpiration, make a difference?
Well,
No grass, no grass.
yeah, that might have, you know, if you have wet, if there's transpiration make a difference with, yes, if it rains and the ground's moist, then it's not going to absorb heat as well, whether it's dirt or grass. There's a fine line between grass and
30 days. If the vegetation is sucking up the moisture and then transpiring, that's going to control the atmosphere.
yeah, a little bit, yeah, that would have more to do with the relative humidity in the vicinity, and that would affect more of the overnight low temperature than anything else, I would think. If you had a lot of moisture on the ground and it was evaporating into the atmosphere and doing that. Yes, sir.
So you showed the variation in the instruments in Jackson and Booth. One would think that there would be some standards.
There are standards, and I think the question was that showed the differences between Jackson and Moose being fairly radical, especially in the summer months. And it's just you know, the thermistor probe is probably calibrated correctly. It's just the housing it's in is not. And I think the one in Jackson went in back in 2002, I believe. They started using that one, which was the bigger housing for the thermometer. And then somewhere along the line, they switched to this Nimbus one. So Nimbus, whoever makes that, I think it's I can't remember the name of the company, something Logic. I think maybe they got the contract for the weather service weather stations, but I'm not totally 100% sure on that. And the Snake River station is
There are some, there are about 5 or 6 chat questions, yeah.
oh, there is.
We have time to go over those or? it's
I don't
not-
know, we'll see. I have to read.
Oh,
Moran versus Jackson not mentioned. Variation in elevation of the two locations significant. Yeah, the difference between Jackson and Moran is significant because it's almost 400 feet. Again, Moran has the record cold and
hello?
that should be a cold spot. And then the other question is, remember mom and dad saying the old late 40s post office was on the north side of Deloney. So that would put it fairly close. Thanks, Matt, for sending that. So that'd be fairly close to where the Forest Service headquarters is. Is that it, or is there more? I don't, not being a zoomer. Well, I think what you're gonna see, unfortunately, is more National Weather Service, the National Weather Service is responsible for the instrumentation and calibration of these climate stations. I think you're gonna see more of the smaller housing with the Nimbus, so expect temperatures to go up in the summer especially, and for daytime highs. Because of the instrumentation. That's my guess.
I'm gonna have to end the questions now, but Jim will be here for another couple of minutes while we get everything cleaned up and sorted out. I want to remind everybody, March 7th, next talk. Jim, thank you for, as always, a fascinating talk. We have a small present. for
Well, thank you.
Which will be related to climate change, and you'll have to see.
Okay,
So if you can all join me
it's a chunk of ice.
thanking Jim Woodmencey. And, could we get these chairs on this side and those chairs on that side? And thank you everyone for coming. And Bob, come on, I'm gonna ask you a question. Great job.
They seem to go a little long.
That's no problem. We're good.
Well, thanks, Mike. Stick that in here so I don't lose it. So I can,
Yeah, take this all.
all right,
That's really cool, the way that magnifies.
yeah,
That was awesome.
yeah. I call it a spotlight.
Good job, Woody.
Thanks, Bob.
As usual, I have an instrumentation question. You mentioned that they have to reset the max min reading. Reset the thermometer.
Yeah,
Okay, so how do they reset it?
the maximum one just tilt down and back.
Okay,
And then the minimum one has a little, like a floating piece of metal in there.
yeah, okay,
And so it gets pushed up
the column is
and then
pushing that down.
it push. And then you have to actually spin it to get it to settle back down.
Tamp it down or something.
Well, the way they're rigged in there is you pull a little pin up and then you just spin the thing.
Okay.
And it rotates it all back down to its minimum. And then you look at both of those
Make sure that
and
they
to make sure they line up. And then that's your
Right now, okay. You just want me
temperature
to
at
hit the button?
observation on some of those forms.
So
Okay.
the max and min will be the same. I have a little max. min,
Okay,
Yeah.
And I built a.
call me back later.
That resets.
Yeah, it's, how it
Yeah,
resets,
thank
I'm not sure, because you push a button on the front and you hear something moving inside. So I think it's moving.